Welcome back to the channel. In this video, I'll be discussing another question from JEE Mains 24 January 2025 session. So this question is from geometry portion. So let us now see the question. Let the position vectors of three vertices of a triangle be these three. If the position vector of orthocenter and the circumcenter of the triangle are these and this respectively, then find the value of alpha plus 2 beta plus 5 gamma. Okay, so first let me clarify what is orthocenter and what is circumcenter and what formula we are going to use to solve this question. So there are four centers related to a triangle. One is orthocenter, another is circumcenter, so another one is centroid, and the last one is incenter. Okay, so suppose we have a triangle like this. So orthocenter means the intersection point of all the altitudes. So these heights, if we draw the height from here and also the height from here and also the height from here, the altitudes, these means this is perpendicular 90 degree, this is 90 degree, this is 90 degree. So this intersection point, it will be the orthocenter, the intersection of the altitudes. Now moving to the circumcenter. Suppose we have triangle like this again. So circumcenter is the center of the circumcircle of this. Circumcircle means the circle that passes through these three vertices where the triangle is inscribed within the circle. So that is circumcenter. Also there is another definition, which is the intersection of perpendicular bisectors of this triangle. So here suppose we have one perpendicular bisector like this, and here suppose another perpendicular bisector like this, and another perpendicular bisector like this. So these perpendicular bisectors will meet in a point. So this is 90, this is 90, this is 90, and also these are equal, these are equal, these are equal, and these are equal. So perpendicular. So these perpendicular bisectors meet at a point, and the intersection of that point, intersection of those perpendicular bisectors are the circumcenter, and this circumcenter is also the center of the circumcircle, the circle that passes through the 3 points of the triangle. Now moving to the centroid, we have this triangle. So centroid is the simplest one, which is the intersection of the medians. So here suppose we have one median like this, another median like this, and another median like this. So these medians, so these are equal, these are equal, and these are equal. So intersection of those medians is called centroid. And for incenter, again if we draw the triangle like this, so incenter means if there is a circle which is inscribed within this triangle, then the center of that circle is incenter. Also, if we draw the perpendicular angle bisectors like this, angle bisectors. So angle bisectors will meet at a point which is called the incenter. So these angles are equal. So these are equal angles. Okay. So this is the incenter. So incenter means the intersection point of the angle bisectors. Also the circle which is inscribed within this triangle, the center of that circle is also called the incenter. Now in our question it is mentioned that orthocenter and circumcenter. So we need to use these. Also there is a relation. Suppose the orthocenter is denoted by O and the circumcenter is denoted by C and the centroid is denoted by G, then the relation is that, the theory that the centroid, let me write it as G, the orthocenter as O and the circumcenter which is C lies on the same line, and that line is known as Euler's line. So they lie on the same line. Moreover, the important part is G divides the line joining orthocenter and circumcenter in 2:1 ratio. So G divides the line joining orthocenter and circumcenter in 2:1 ratio. Let me just briefly put it in the picture. So suppose we have a triangle like this here, and suppose if we draw the orthocenter, which is the intersection of all the altitudes, will lie somewhere in this line, and if we draw a median, so the centroid will lie somewhere in this line, and also G divides, so G will be here as G divides the median into 2:1 ratio, so G will be somewhere here. And also if we draw the perpendicular bisector, that will give the circumcenter. So this is the bisector. If we draw the perpendicular here, so C will be here. So if we connect these lines, so let me put it in some other color. So this one is the, yeah, so this one is the orthocenter, this one is the centroid, and this one is the circumcenter. So G divides this line OC into 2:1 ratio. So OG by GC equals to, OG by GC equals to 2/1. Okay. So here the vertices are known. So from vertices we can obviously obtain the centroid, and by using the relationship between centroid, orthocenter and circumcenter, we can find some relation. So let me do that. So the vertices are 4p plus q minus 3r. So here 4p plus q minus 3r, and next one is minus 5, 1, 2, minus 5, 1, 2, and the last one is 2 minus 1, 2, 2 minus 1, 2. So these are the vertices. So let me just write it as this one is A, this one B, this one C. These are the position vectors. So from here we can obtain the centroid, which is G, the position vector of the centroid. So A plus B plus C divided by 3. So we will sum this, and dividing by 3 we will obtain. So 4p minus 5p, there is minus p, and 2p, it will give plus p. Q plus q, 2q minus q, so it will give again q, minus 3r plus 2r, which is minus r, and there is again plus 2r, so it will give r. So this divided by 3. So we have obtained the centroid. Now let me write the circumcenter and the orthocenter. Circumcenter is given as p plus q plus r divided by 4. So p plus q plus r divided by 4, and the orthocenter is alpha, beta, gamma. So this is alpha p, beta q plus gamma r. Okay, this is orthocenter. Okay, so from here we can see that OG by GC, OG vector will be twice GC vector. So we can use that. So from here G divides this in the 2:1 ratio. So their magnitude is, the magnitude of OG is 2 times the magnitude of GC, and also they have same direction. So this one, this vector OG, this vector, wait, not here, so this vector OG will be 2 times vector GC. Okay, so we are going to use this one. So vector OG equals to 2 times vector GC, vector GC. So OG means position vector of G, or let me only write down as G vector. G vector minus O vector, and twice C vector minus G vector. So G vector is this one here, and C vector is this one here. So yeah, we have P plus Q plus R divided by 3 minus P plus Q plus R divided by 4. It will give 2 into C minus G. So O is this vector, and circumcenter is this vector. So we need to exchange these. This is the orthocenter, and this one is the circumcenter. This one is the circumcenter. Okay, so now it makes sense. G minus O will be G minus O, this minus this, and the C minus G will be this C minus this. So alpha minus 1/3 P, beta minus 1/3 Q, gamma minus 1/3 R. So alpha minus 1/3 P plus beta minus 1/3 Q plus gamma minus 1/3 R. So if we simplify these, we will obtain 4 into this minus 3 into this, and the LCM will be 12. So it will give P plus Q plus R divided by 12 equals to 2 alpha minus 2/3 P plus 2 beta minus 2/3 Q plus 2 gamma minus 2/3 R. So by comparing both sides with P, with the coefficient of P, coefficient of Q and coefficient of R, we will obtain 2 alpha divided by 2/3 equals to 1 by 12. So it will give 2 alpha equals to 1 by 12 plus 2/3, which is, here we will obtain 1 plus 4 are 8, 12. Okay, wait. 2 alpha. Okay, so let me put it in this form. It will be much easier to solve. So 2 into alpha 1/3, it will be 1 by 12. So alpha equals to 1/3 plus 1 by 24. So it will give 8 plus 1 by 24. So 9 by 24, it will give 3 by 8. So all this alpha, beta, gamma. So other equations are also same. 2 beta minus 2 by 3 equal to 1 by 12. From here 2 gamma equals to 2 by 3 equals to 1 by 12. So all these values, so alpha equals to beta equals to gamma equals to 3 by 8. So we had this expression alpha plus 2 beta plus 5 gamma. So alpha plus 2 beta plus 5 gamma, it will give 3 2s are 6, 3 5s are 15 divided by 8. So 24 by 8. So the answer is 3. So let me now check the option. So there is a option 3. So this one is the correct answer. So if we know this thing here, this relation that the centroid divides the line joining orthocenter and the circumcenter in the 2:1 ratio, if we know this statement, we can easily solve this question. Otherwise we can't do anything about it. So we need to memorize these formulas. These small formulas are very useful in solving these questions. So thank you for watching this video. Please like and comment on the video and subscribe to my YouTube channel. Thank you.